All right. What we're going to talk about now is how to use the properties of functions when given a graph. This seems to be the most troubling thing for students is that they know how to do it algebraically, um, maybe even numerically, but when they have it graphically, there doesn't seem to always be a connection. So we're going to go through a few examples on how to do this. Well, first off, you need to first read the statement and identify the graph. So I have a graph here that I've created of two very simple functions. I have f, which is in orange, and then I have g right here, which is in pink. All right, and what we're going to do is we're going to find these different values. So first off, we're going to have is we're going to find what is f plus g of x. So what that means is we're going to be looking for f of 4 plus g of 4. Now, to do that, we're going to find these different values by appearing and looking at a graph. Okay, so we're going to say, okay, what is f of 4? Now, f of 4, we have to go over and look at function f, which we know is going to be, let's move this, all right, which is the orange function given right there. And I'll delete those just so I can see a little bit better. All right, and so we have the orange. So we go over to 4, and we determine, okay, 1, 2, 3, 4. I look up here, and we have number 4. So the value is 4. Right, and that's a g of 4. Well, g of 4 right there, it appears to be 2. So f of 4 plus g of 4 happens to be 6. So if I were to write this combination, I would have at 4, my output would be 6, and I can plot that point for this new function. Okay, I can do the same thing with subtraction. All right, if I want to find what g minus f of negative 2 is, I would say, okay, I want to find g of negative 2 and subtract that from f of negative 2. I want to find those two values. All right, that's the easiest way of kind of looking at it. So over here, I look at what is g of negative 2. So g is my pink's value, so 2, and I have 1, 2, 3, 4. So that's be 4 minus f of 2, all right, or f of negative 2, which would be f of negative 2 is going to be 2. It just happens to be the same thing. That's what I get for making graphs that are just shifted over and reflected over each other. And we have 2. Okay? You're not always using the same values if you look at the previous problem. It just is a coincidence in this case. All right. We can do one more, and this is a little bit harder one. And I have a composite here, but we could do addition and subtraction, multiplication, and division. But here I have fog, which means this is a composite symbol. Composite. And composite, if you watch the other tutorials, means we're going to go f composed of g of 2. Now this is where it gets a little tricky, because whenever you do composites, you always work inside out. So composites inside out. All right, because in order to find f, I have to know what I plugged inside of f. I need its input. Well, to figure out what the inside of f is, well, that input is g of 2. So what is g of 2? I have to figure out the output of first of g of 2. So I'm going to first find g of 2. So I look over my graph, and g of 2 is going to be 1, 2, and it's perhaps to be 0. All right, so g of 2 right there is 0. So since g of 2 equals 0, I'm going to plug that in. And so now I'm looking for what is f of 0. F of 0 is right there, and that also happens to be 0. So my value right there is 0. And I like doing my little donuts there, but that's my value for f composed of g of 2. Okay? Well, let's try some other ones right here. And I'll actually save this one for later. That's a little tricky. All right, but here are some other additional ones. And let's find these. It's a different graph. All right here. Okay, so let's find these. All right, I'm going to pause it and try these out yourself, and then continue as we go through. All right, and I'll tell you the answers. Okay, well, here we go. F of g of 2. So that means I'm finding f of 2 divided by g of 2. So in order to figure out these values, I have to go on to the graph. So I'm looking for what is the output when I plug in 2 into f. So look at function f, and here's function f right here. Here's f. So I look over here and say, okay, at 2, I have a value right there. I'm going to use a different color than black right there, which is lined up with 1. So that's where I get 1. All right, so that is f of 2, which equals 1. Next value, I'm looking for g of 2. Well, g of 2 is right there. That is g of 2. And g of 2, it appears to be, I don't know, probably like 1/2. If you had to estimate. All right, it's going to be 1/2. So now we have All right, 1 over 1/2, which happens to be 2. So my value is 2. Next ones we're going to have, I'm going to erase this, okay, is we have g composed of g of 1. So that means I have g composed of g of 1. So remember, this is a composite. And to solve composites, you always need to figure out inside out. So you need to first figure out what g of 1 is. So look at g, which is this function right here. And when I look at g, I'm looking at g of 1, and it happens to be 0. Okay? So g of 1 is equal to 0. So I plug in 0, because that's my output. And now I have to do the next step. All right? Now I have to find g of 0. So there's many steps to composite. Like I said, if you watched my other tutorials, composites are like onions, which are like ogres, because they have layers. So many different layers we have to do with this one. So, but we look over here at g of 0. G of 0 is equal to -1. So my answer to g composed of g of 1 is -1. And that is my solution. All right, hopefully that's making sense to you. Let's try another one. I'll make this one green. So here we have another composite. Now, in this composite function, what we have here is g composed of f of 3. So once again, we're going inside out, inside out, inside out. Okay, inside out. And I start with the inside because I have to first figure out what g of f of 3 is. I have to know what f of 3 is. So I go over here, f of 3, and f is my function, and 3, so that is right there. That's the point I'm looking for, f of 3, which equals, it appears to be 2. So I plug that in there, and now I look for g of 2. Well, I look at g of 2 happens to be right here. G of 2 is 1/2, and so my value is going to be g composed of f of 3 is 1/2. And that's what we have. All right. Now, figure out the remaining ones in this last one here. This is where also students get a little confused, is that would get a problem that is f without no thing. I shouldn't even have that. This is actually, get rid of that. It should be just f times g of x. That means multiplying. So I'm taking f times g of x. Now, students see that and are like, what? What is it saying? Well, that is saying, actually, I am wanting an equation. All right, or I want to know the graph. So I want to know all the outputs for this function. So actually, I'm creating a function, an equation on this. Now, you might be asking yourself, I'm looking at this, and I do not see an equation. This would be so simple. All I see is lines. Well, that's what we have to use, because equations help us make points, which help us be plotting graphs, and we're going to be creating a table to help us figure this out. Now, to help us figure out what this new function is going to be, we're going to have our inputs, and then we're going to get our outputs, f times g of x. So we're going to take all the outputs, and we're going to multiply them. All right, the f outputs times the g of outputs. Remember, this is f of x times g of x, and all of these functions equal y values. So we have y1, we'll call that one, times y2, which would be g of x. So that's what we're going to do. So if you notice, our points are kind of lined up. We have a point at 0. We have a point at 1. We have another point here at 2. And we have another point here at, appears to be 3. So we're going to find those values. So we're going to, each one of those values, I'm going to find what it is. So 0. At 0, for f is going to be 2. I take 2 times -1. And what I have then is going to be -2. All right, -2. Now, in the next one, I have 1. 1 is going to be, for f is 3 times what we get for g, which is 0. So 3 times 0 is 0. At 2, I have for f is going to be 1 times what I have for g, which is 1/2. So that's going to equal 1/2. And for 3, what do I have here is 2. And then 2 times 0, which I get is 0. And so now I have my values, and so I can actually graph this. So I'm going to graph this in blue, and I have 0, -2, 0, -2. There's 1 point. I have 1, 0. That's a point right there. I have 2, 1/2. All right, and I have 3, 0. And I connect the dots, blah, blah, blah. And we have that as our values. Okay? Now, seeing this, you can probably ask yourself which values, all right, um, which values influence the range more, all right, which function? Well, it appears right here. Well, actually, you can say this is negative, but the 2 for f influences this point more. Right here, obviously, g influenced it more. All right, this one actually looks like g influenced it more because it's times 1/2, and then this is 0, so g influenced it more. But when you have multiplication, that's what we have for a graph. So whenever you have f times g of x, you're looking for a graph or an equation of those values. And for when you have a graph, just take common points and go and find the solutions. All right. Well, I hope that helped. You understand more about how to use these properties of arithmetic and composition of functions to help you solve problems involving graphs. All right. Good luck on your homework or in the rest of your math problems.